Hello everyone, welcome to the field. I'm Leanne, and today we are demonstrating how to conduct droplet characterization for a Vectoback WDG truck-mounted WALS application. It's really important to conduct your characterization to ensure that you have the proper drop size and number to achieve success. We're gonna need a few items before we get started. First, we're gonna use chrome coat cards or photo paper. They are cut into small pieces, 7 centimeters by 9 centimeters. Each card is labeled on the back according to its location on the card line and what run number we are on. For this evaluation, we typically use about 11 cards per run. So I've collected 3 runs and 33 cards. We will also need your basic plastic CD case. The CD cases are to hold the chrome cards in place at the location. We just use standard clips to clip them onto the CD cases. You'll also need some cones or flags to mark the location of each station along your card line. Also, we'll need a tape measure at least 300 feet, which is what our swath will be today, to measure out where the stations will be located. We also need some red food dye. We typically use red dye number 40 so that it's safe for the environment. The red dye is mixed into the product during the mixing process and is used so that we can see the droplets on the chrome coat paper to complete the droplet analysis. Typically, we only need 0.06 pounds of red food dye per gallon of mix. So for this evaluation, we just have a small amount of red food dye. You also need to monitor the wind speed and direction, so we have a simple handheld device to do that. All right, let's take a look at our test layout. Here's what the characterization card line setup will look like. We have a 300-foot card line with droplet collection stations every 30 feet, from 0 feet to 300 feet. The card line will need to be set up in the direction of the wind at the time of characterization. The driving path will be perpendicular to the card line, and we will drive between the first 2 stations at 0 feet and 30 feet. As a truck drives down the path, the spray cloud will drift over the cards, collecting droplets as they fall. Now that we have all of our supplies together and the perfect area to conduct our characterization, let's get things set up. Before we set things up, we're gonna first check the wind speed and wind direction to make sure that we set our card line in the right direction. Today it seems as if the wind is coming from the west, so we'll be setting our card line in this direction, to the east. All right, let's get our card line set up. Now that we have our card line set up, let's prepare the cards for the first run. As I mentioned earlier, each card is labeled for the run and the location that it will be on the card line. I labeled them on the back upper right corner. To place the cards, you want to put the glossy side up and attach it to the CD case towards the top, and use the clip to just hold the card down just at the very top of the card. Then you place the CD case and card at the correct location. Let's go ahead and get all of our cards out on the card line. Now that we have our card line set up, we're ready to go. We want to conduct droplet characterization after inversion occurs, so we'll return tonight to complete each characterization run. Welcome back to the field. The sun is set, inversion has occurred, and the winds are perfect. We're ready to conduct our droplet characterization runs. Everything is set up, and the labeled chrome coat cards for the first run have been placed out. Now it's time to get the equipment started. It's important to conduct characterization runs using the same parameters as you would for normal operations. For us, that's 10 miles an hour with the boom pointing straight up. We're stationed about 200 feet from the card line. There's a cone placed here and another cone placed 200 feet past the card line. We're going to turn the equipment on, drive 10 miles an hour, and drive in between stations 0 and 30, perpendicular to the card line. Everything's set, so let's get started. That looked good. Now we're going to give the spray cloud some time to drift across the card line and settle. We're going to wait about 30 minutes to make sure that everything is settled and that the cards are dry before we pick them up. The spray cloud is settled, the cards are dry, and we picked up the cards from run 1. While they're placing out the cards for run 2, we're going to quickly run droplet analysis on this run so that we can make any adjustment to the equipment if needed. Droplet analysis is a quick and easy process. We're in the back seat of the truck and I have my SnapScan scanner hooked up to my computer. I'm going to simply scan each card into the computer and save them in individual files. It's important to scan the cards in order so that the program can graph the data appropriately. Once we have the backdrop program open, we're going to enter a few parameters such as the size of the card and the distance between each card, and the backdrop will do the rest. Backdrop calculates the volume median diameter, or VMD, the number median diameter, or NMD, both in microns, and the drop density on each card across the 300-foot card line. Number median diameter, expressed as NMD 0.5, is the value that divides the spray into 2 equal parts by number of droplets. Half the droplets are smaller in size, and the other half are larger, without reference to volume. Backdrop creates 3 important files. First is this Excel sheet, which is the raw data for each card across your 300-foot card line, where it tells you on each card the total number of drops, the average VMD, the average NMD, the droplets per square centimeter, and the location of each card. The next graph is the overall VMD and NMD. This graph illustrates the average size in microns of VMD and NMD with the droplet size on the x-axis. For WALS applications, it is recommended that we have a drop spectrum of fine to extremely fine, which is about 36 microns to 236 microns. You can see here that our VMD 0.5 is right in the middle of that at 126, and the majority of our drops are 218 microns or smaller. This is a great spot for WALS applications. The last graph is the drop density and the individual VMD across the 300-foot swath. You can see here that we have plenty of drops all the way across our 300-foot swath, all in the right size. This is a perfect setup for WALS applications. We will repeat this process 2 additional times to ensure that our equipment is consistent. But at this point, our equipment is operating properly for WALS applications. That's all it takes to conduct droplet characterizations for your truck-mounted WALS equipment. Thanks for tuning in.